You don't have to throw away your scripts and playbooks to use network orchestration. With Itential, you can keep your automation code and add rich workflow orchestration to it. Visit itential.com to find out more. That's itential.com. Welcome to Heavy Networking, where today I'm going to ask a question that it's going to annoy the heck out of some of you. I mean, maybe most of you. We'll see. I am Ethan Banks, along with fellow host Drew Conway Murray, and you can follow Drew and I on LinkedIn, Blue Sky, and the Packet Pushers community Slack group. Please follow us, DM us, and otherwise signal that you're a sentient human in those places. I'm kidding, not kidding, in that I am seeing quote-unquote people join the Packet Pushers Slack, and as I look at their profiles, they look not sentient, just an AI that's playing along. And when I figure it out for sure, I boot them, because I needed another admin task to do, fun. And speaking of fun, our guest today is Scott Robohn. He is going to chat with Drew and me about that annoying question I warned you about, and that question is, could an LLM or some kind of an AI-driven language model someday replace our beloved command line interface? Is that possible? And I think I have opinions. I have opinions, Scott. I have opinions, Drew. And but let's talk to Scott first, in case there's some of you out there that don't know who Scott is. Scott, thank you for joining us. Would you please tell the nice people out there who don't know you who you are and what you do, especially since you're a host of your own podcast on the Packet Pushers Podcast Network?
Well, I am a very happy and grateful host of Total Network Operations here on Packet Pushers. It's been an incredible experience for me. I'm also a co-founder of the Network Automation Forum, and I'm the co-founder of a consulting company called Solutional, which is a horribly wonderful and non-specific name for dealing with all sorts of technology engagements.
Those are the best kind of company names.
That's right.
What is it we do? You know what? Just generic name it, and then it's open. We can pivot when we need to and not have to rebrand.
It does allow for a certain amount of flexibility, but just so people know where I'm grounded, I'm an internet plumber. I've been saying 35 years, but I realized starting with co-op assignments during my undergrad, I might be able to claim almost 40 years of work experience now. Not all strictly networking, but certainly the majority of networking and cloud. And now, what we're doing with AI for network operations, and we're going to dive into a piece of that today.
All right, thank you for joining us in Heavy Networking. And again, if you kind of glazed over when Scott was talking, check out Total Network Operations on the Packet Pushers Podcast Network. If after this conversation you think Scott is worth listening to, because he is, or he wouldn't be here. Okay, so let me set up this conversation for today with you. So Scott and I attended an event in New York City, a one-day event put on by the company Selector.ai. And they've been a Packet Pushers sponsor. You've heard from Selector before. If you've listened to Heavy Networking, you've heard from them recently. This is not a Selector conversation. It just so happens Scott and I were at this event where we were talking about a lot of AI for network operations stuff hosted by Selector, and that's the context here. One of the big ideas that came out of that day's worth of talks for me was this idea that drove the annoying question. Could a language model, large language model, small language model, something driven by artificial intelligence that we talk to in plain language, take the place of the CLI? Therefore, those of us that were Cisco certified, Juniper certified, and prided ourselves on knowing the command line syntax to configure esoteric things and make the network do stuff, make the blinky lights go blink, would that be obviated? That is, would we not really need to know syntax anymore? Because in plain language, I can say, hey, language model, I want the network to do X, and it just does it, and we don't need to know CLI anymore. The same thing for our infinite list of show commands we prided ourselves in learning. I need to know the status of this VLAN, whatever it is, and you punch in a show command or a show IP BGP or a show BGP, as the case may be, and get some kind of an answer back. As opposed to, hey, language model, would you tell me the status of BGP in Chicago? And that's it. And it gives you an answer that is relevant and important. Now, this isn't as simple of a conversation as you might think it is on the surface. It gets complicated. And that is really what we want to talk through today, whether or not this is feasible from a network engineering perspective. And what the implications are. So Scott, just first of all, do you think the question I've posited is this a straw man, or is this actually something worth talking about?
It's worth talking about. it's real and becoming real. Let's put some guardrails around real. So much is new and changing and developing with the use of AI and machine learning in NetOps and other technology areas today that I don't think we can say any of it is perfect, right? And that's certainly true when it comes to being the only way to get status information, impart config information, but it's not just selector, right? And we'll just name names because we live in the real
Yeah.
world, right? We're seeing Meter do this. We're
Yep.
seeing Nokia do this with the data center EDA solution. We're seeing Extreme Networks do this in their management system. I'm sorry, I can't remember the name of that tool set right now. And I'm sure there are others that are doing the same thing, not like all exactly the same way, but
Juniper, got to say Juniper or HPE now.
yeah, we can still say Juniper. It's just going to be hard for me to not say Juniper for a very, 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 very long time for reasons you already understand. But it's like the T-shirt in the '80s. Eat Russian fish, 100 million, or eat American fish, 100 million Russians can't be wrong. If so many vendors are investing in this, there's definitely a dog that will hunt here. And we're seeing varied results, right? I know, Ethan, you've been playing with some things that have, you've seen some interesting results here, but the short answer is this is real.
I've worked a little bit with the tools, or at least seen a demo. So like Nokia, there's a video on the Packet Pushers YouTube channel of Nokia showing off that plain language capability. Meter, there's a video that has, as of this recording, hasn't been published yet, but it's in production right now. And I spent quite a bit of time with their interface called, I believe they call it Command. That is a natural language where the intent, Meter's intent is anything you can do in the UI, in the regular dashboard, graphical user interface, you can do at Command via just plain English. So that's it. Yeah.
I've seen different modes of it being implemented. In particular, I think it's the Nokia EDA system where when you say a command, you actually see the command line output that the LLM, I assume it's an LLM that they're using to process your voice commands, and you get very detailed information of the actual command line that'll be issued. So there's like an interesting built-in QA check there where if you're someone who has subject matter expertise, right, you know how to drive the CLI, and you're trying, voice commands, or dare I say, expressing intent in your most natural form. Is this really intent-based networking? We can go there in this episode. But you can catch errors, right? Or you can see, oh, that's not exactly what I meant, and you can actually go and edit the CLI command as well. That's, I think, super useful in these early phases of experimenting with this. What about your variability, Ethan? I know you've seen some, hey, I've said this the same way, and I've gotten 3 different answers 3 different times.
Okay, so you're hitting on an important question here that we need to talk through, which is a deterministic versus non-deterministic and what that means in a computer science perspective. So if we take a step back, and then we're going to get to that variability question you asked, Scott. Deterministic means for the same set of inputs, you always get the same output. That is, if I feed an algorithm a certain set of information, a deterministic approach means I'm always going to get the same answer every time. Non-deterministic means there's some element of randomness that is inserted in the algorithm. That means you have some variability in the answer. If you're a network engineer and you ask a system a question, especially a question that involves a number that you're expecting to come back, or a black and white yes or no sort of response, or I need to know the state of this particular state machine, you want a firm answer, a deterministic answer. But large language models, by their nature, are non-deterministic. That is, as they follow as I understand this, and Drew and Scott, fill in details if I'm getting something wrong here, but as an LLM follows the particular paths it can through its vector database to give an answer, its intention is to be non-deterministic to a point. There's a degree of variability because it lends a human quality to the answer you're getting back rather than the exact same robotic computer response every time. You get some amount of variability. Well, if I'm a network engineer, I don't want variability in my answers, please. I must have the actual truth. I must have the actual answer. And so hearing deterministic versus non-deterministic and then hearing LLMs are non-deterministic freaks me out because I need to know exactly what is going on, not I inserted some creative randomness in my answer because I want to feel more human. Well, I don't want you to feel more human. I want you to tell me the exact truth. Now, there's more to the story here that we're going to get into, but in some work that I've done fiddling with LLMs, I have noticed I put in a question and get multiple different responses back, including different numerical answers like, that shouldn't be. Those were close numbers in answer one and answer two, but they should be the same number. What is going on right now? And this again came up in the New York City event that we were at, Scott, where this was talked about from the platform, because you can, when you are in control of the model, control some of that variability so that the result you get is more deterministic or is in fact deterministic.
Well, and not only just the control of a single LLM, but based just on what we saw from Selector, there's this use of multiple models and computational techniques underneath the hood that can also be chained, combined, probably some parallelism versus some chaining to help shape those characteristics. Then you have all the other model parameter tunable items like temperature, right, and other mechanisms where you can force things on one neural net path more times than not. And that's horrible oversimplification of, I think, what's going on internally. But there are ways to steer it.
What do you mean by temperature? That's not a term I've heard before.
Temperature is an element of model training that I am already ahead of my lights in talking about just by mentioning it in this context. Ethan, you've looked at it a little more closely.
Well, I don't know if it's training or inferencing or both. The context I think I'm aware of it in is inferencing. That is, so say you go up to Google's AI Studio and you play with Nano Banana to make up an image in response to your query. You can set temperature. Temperature is a number from 0.0 to 1.0. If you put in a temperature setting of 0.0, that means the LLM is going to always select the highest probability token next. The closer the temperature gets to 1, the more random it might be, and it might choose a token next in the path that's less probable based on its training. And so you get more randomness in your answer, more of that human element, I guess. Although, yeah, I guess is it an LLM if we're creating images? I don't know. Anyway, but that's a setting that's right there. I mean, you look in the settings of the Google AI Studio, temperature is a thing that you as the user can set yourself. And I believe it defaults to 0.7. So you get something that's a little more random and a little less, deterministic, if you will.
Okay, so the idea here is that if I want to move more toward the deterministic side where I'm getting the same output based on the same input every time, I would adjust the temperature accordingly.
And that's just one of the variables. Adjusting temperature to 0.0 by itself will not necessarily result in a deterministic answer, but it's one of the variables that can be set. There's a whole bunch of other things. That was just one I grabbed as an example. Sampling method is another, and then beyond that, there were people who are not public but were at the event, but we can't talk about them here, mentioned programmatically how they were influencing some of the results they get from a model to end up with a deterministic answer.
And I think, Scott, you started to talk about this and I sidetracked us on temperature, but what I'm also understanding is we're sort of talking about an LLM as one entity that's doing everything, and that's not really where it seems like the industry is going. There are going to be sort of special purpose models doing special purpose things that communicate with maybe another LLM that's doing the communication back to the human front end.
Correct. And I would even expand it to the following way. AI, whether we're talking about LLMs, machine learning, RAG and other techniques that fit under the AI umbrella, they're a new set of tools. Computational techniques is one way to think about them. And they don't totally get rid of other computational techniques that are still really useful, like graph theory, like statistical regression, like linear integer programming, right? It's just more tools in the tool box. And now, as system architects, people have more decisions to make on, I have this use case, and let's make sure we peel apart, natural language interaction with a system is actually a set of use cases. It's not just one. Some combination of computational techniques might be more effective for one use case or set of use cases than another.
One set of data versus another.
Correct. Yep. And so in one of the vendors that we're talking about today, I had a conversation with them a few weeks ago about a long-term effort to automate operations within a large network. And I said, so how quickly are you going to get to autonomous behavior? And the response was actually pretty measured and conservative. Hey, we're just taking one workflow at a time and making sure each workflow works. Mm-hmm. So I think that was like a huge aha on the vendor technology supplier side. They don't have a one tool fits all use cases mentality, at least the smart ones, right? And want to be really careful about building trust in these systems that they say will help us get to autonomous behavior. Does that make sense?
Uh-huh.
I think it's also important to point out that the LLM that all of us keep talking about, because that's the thing that's blown up big in the AI world over the last few years, is just one piece of a much larger set of AI models, where the LLM basically sits at the top of a whole bunch of other models and their data,
right?
And just gives you an easy way to interface with that other data. There's other models that are going to be gathering data and coming to answers and conclusions in a non-LLM kind of way. And again, the purpose of the LLM is mostly just to translate what you're saying in plain English and then figure out how to get the data you're looking for out of those other models.
And I think so. If we split hairs on what do the natural language use cases look like, there are the very simple cases of speaking a command. And just like we have, so many devices that hear us and translate what we say into commands, maybe on devices in my office here that might be listening to me right now, and I don't want to say the wake word to activate said element. That's one level of sophistication. I'll pick on you, Ethan. You made I think a mostly funny comment as we warmed up here on, show me what my BGP looks like. And there isn't one command that shows me what my BGP looks like unless I'm using wildcards or dare I say it, regular expressions. And there's a trade-off here. There's the variability versus how easy is it for me to see the state of all my BGP peering connections on a given router or a set of routers in a given location. Even if there might be some variability, there could be extreme power in being able to, show BGP neighbor for a bunch of neighbors and summarize that info.
In fairness, there is technology that does that. I mean, look at what Dinesh Dutt is doing with Suzy Q and so on. That's his whole approach, is talk to the network as a whole. And I don't know how much AI he's got in the back end. If I remember right, it isn't much. So there are ways to approach that. AI is just a different way. Now I wish Dinesh was here because I could say, how deterministic is your solution, Dinesh? Because I bet the answer
there's a follow-up.
Very.
Don't cut yourself off from a follow-up conversation. There you go.
Right? There you go.
Yep.
And now a quick word from Packet Pusher sponsor iTential. In my Python work, I have found that there is lots of power, but lots of detail. The deeper I go into the code, the more challenging it gets to keep the network up to date as I intend in an automated way. And as a result, I tend to write a script that does a specific thing predictably, and that's it. Now, if I am honest, I am not as disciplined as I should be about error handling. I start off with a script that works fine most of the time, but if it fails, I do not always have the code for that, and I say this to my shame. And the problem is compounded if I were to try to integrate a bunch of other systems together beyond just the network infrastructure, such as updating the source of truth or acting on telemetry or reacting to network discovery, interacting with ServiceNow, etc. This is where Itential makes fantastic sense to me. I want a platform that helps me handle those interactions, that makes it easier to handle exceptions, that can execute a rollback if a change didn't go well, that can talk to any API I need it to without it being a big deal. In other words, Itential's tools give me a platform that I can build an orchestrated workflow system on top of, no matter what my company's tool stack looks like. And I can do that all while integrating scripts and playbooks that I've already written. I don't want to have to throw all that work away just to use Itential, and I do not have to. Itential just makes what I've created work better and plug into my company's IT infrastructure. To find out more about Itential's products and how they help you build a network orchestration platform that integrates with your business, visit itential.com. That's itential.com, and tell them Packet So Pusher that sent you. is an advantage here, being able to talk to the network as a whole. And I think thinking about the network holistically is an important element of this. That's something we've been moving towards for, dude, how long now have we been building, like go all the way back to the 2010s and building fabrics and, the networks as a whole. And then, the controller with sending SDN, doing the SDN thing and pushing that down into the fabric. And, so treating the network as a whole and thinking about it as a whole, what Big Switch Networks was doing, that paradigm. An external switch is now a line card in a much larger thing, only it's been externalized. And, the chassis fabric is now just a bunch of cables.
Right.
We're getting to that point again in yet a different way. Although, as I'm thinking about it, it's like, man, we're doing it with models that take a huge amount of power to do what they do. And I mean power, both electricity as well as computational power, beyond the scale of anything we've seen. And I saw a number, we're talking about $1 trillion worth of spending on AI between now and 2030. And I was like,
that seems low. That number seems low, actually. Yep.
Right. And from some of the other conversations we've seen and some of the stuff Sam Altman's talking about, he's talking about more money than there is to be able to fund the thing that he wants to do. Like, okay.
That's what you get from going away from the gold standard. Sorry, did I just say that out loud? So,
Oh boy.
I mean, so I think we're getting into the question of, there's one question that we've been kind of hitting on so far, which is this technically viable? Is it conceptually possible that a language model paired with a bunch of other AI models ingesting all of my network data being a whole other discussion to have? You got to have good data, you got to have clean data, deduplicated data that can be ingested into the model and absorbed appropriately. That's another thing. But assuming we get by all of that, is this technically viable? Let's say the techniques are there. We can do it. We believe AI, and if we train it right and the data's good and so on, it's there. We can do it. Is it practical? Can we actually make this thing go? I had published on LinkedIn summaries of several of the talks out of the Selector NYC event. I didn't get to everybody. I just ran out of time, but I published several. And one of them was it was a summary of, I believe, the overview of the Selector architecture. Maybe it was the keynote intro, but either way, a comment I got back from somebody was like, the power you need to actually pull this off is astonishing. You need to have a huge amount of compute power to actually ingest all this data. And don't forget it's real time and how much telemetry we're going to be pumping into the models. It's not a one and done where you can, like Claude will tell me, I use Claude to ask various questions of, I don't know anything past whatever the cutoff date is, January 2025 or whatever the cutoff date was, but I'll go search the web and see what I can figure out.
Yeah.
Okay. You don't have that with network engineering. You can't have a cutoff date. The cutoff date is never. Right. I need everything now, and I need you to be able to tell me in real time what's actually going on, especially if you want to apply artificial intelligence to problems like like Lumen was talking about in
Yeah.
NYC. We need to rebalance our circuits in such a way that this one overloaded circuit is evenly and appropriately distributed to all the other circuits that we could redistribute some of that traffic to without causing yet another problem. How do
Right.
we do that? And they're using heavy math to figure that out and then make that happen. Well, it's useless if the data they have is 30 minutes old or 60 minutes old, et cetera. You
Sure.
need to know now, what's going
Right.
on, and then be able to make that rebalancing decision for it to be effective before your traffic patterns have changed again.
Right.
Again, going back to the compute power you have to pull this off is not insignificant. This is kind of a big deal. It's not going to be a couple of
Right.
boxes you rack up and you're done.
So you're not wrong, right? And that's, if you look at, I live very close to Data Center Alley in Ashburn, Virginia, right? And those large gray buildings with no windows have been going up for a very long time throughout the course of my career there. It's been kind of amazing to watch. And now you see the local community there. There's a lot more public pushback on building yet another data center, and not just because of power, but because of a grouping of issues. That's creating opportunity in other parts of the country and the world, right? There are other markets where more data centers are going up and where there are different types of energy available in different places, right? Hydro is much more available in the Pacific Northwest than it is in Arizona, for example.
Yep.
I think wherever, the process of site identification and selection for building a data center, whether it's plain old vanilla data center or neocloud, very focused on GPU housing, energy and heat removal are probably the two biggest issues associated with site selection today. What's that going to do with nuclear and small modular reactors? It's gaining steam, no pun intended. But I would say
Stop.
I don't want to be tied into any one energy source anywhere. I want diversity in my power supply. And if I have abundant solar with good battery technology, I should be leveraging that in a location. If I have good hydro, I should be leveraging that in a location. If I have good wind, I should be leveraging that in a location. I also leaves the door open for fossil fuel use too, and nuclear, right? I think that's got to be a really, really important planning discussion along with environmental impact for this whole power consumption issue.
If I am a enterprise consumer of AI, how much of this power calculation should I be considering in terms of my own infrastructure costs and infrastructure operational needs? Because my assumption is most of the power consumption and cooling and so on is happening in the big giant data centers where the models are being trained. They're shipping me something that's essentially cooked and ready, and I'm just running it on a few servers. Is that not right?
No, the reality is the reality. If you ask me the question, are enterprise IT organizations thinking of this top of mind right now? My experience is almost 100% no.
Mm-hmm.
They're still thinking through the basic decisions of, first somebody told me I need to build my own AI infrastructure, and they saw the costs and the technology, technical proficiency that I would need to actually maintain my own equipment. And so many are realizing, yeah, this is not what I need. So now I'm going to either buy those services in my standard cloud, and what I'm going to care about is cost, right? Not necessarily, what the energy cost or energy impact of that is, or whether I'm going to put it in a neo cloud provider. And again, I'll be thinking about cost. I know that NVIDIA. Yeah, go ahead.
Yeah, I'm thinking about, not to harp on a specific vendor, but Juniper, they've been doing AI ops now pretty successfully for several years, and I have not heard people push back on Juniper being like, your devices are too expensive to power and operate in my network. So
I think we're agreeing.
What is this leap that we're making? Yeah.
Well, it's the awareness of the real impact of the power hungry model training activities.
Okay,
right?
but to be perfectly hold I as an enterprise, if I'm an enterprise, this to me is an externality to my
Correct.
company operations.
Yeah.
The fact that OpenAI is eating all of the world's electricity, I don't care as long as I can run my business and not have, I'm not necessarily paying that cost directly, is what I'm saying.
Correct.
Uh, I,
You're
I
not,
think
you're not paying it
I think
directly.
that's
You're
mostly
not paying
true.
it directly. Yeah,
Uh-huh.
you're not, but you're not. I'm with Drew on this one. You're not paying it directly. You might be paying it indirectly
Right.
someday. Yeah.
Yeah.
Well,
Okay.
there's another question of where are you actually going to do your training? If we go back to the networking context and you care about all that data being private and maybe you're not going to ship it up to, a neo cloud and run your
Yeah.
selector instance or whatever. You're going to run it in-house. Well, then there's some kind of an equipment stack you need to pull all of this off. What does that look like exactly? I don't know, and of course it's going to depend on the number of events, the size of your network,
Sure.
and a lot
Yep.
of things there.
We have some important history on this point. And just to put a specific point on that, Selector does support private instances for everything, right? You're standing it up in your own network, and you get to keep all that telemetry and observability data stays with you. So they seem to be pretty good on those privacy concerns, and they don't seem to be driving lots of energy requirements with the small GPU footprint that their systems need. Stand by. That's something we should all be evaluating, right? But let me point you both, since we love to talk about history and 15 years ago, remember the cloud. There is no cloud. There's just someone else's computer. And remember how hesitant we were to put my data or anything in the cloud. That's not secure. That's not my facility, right? And I was dealing largely with carriers at the time, and there was like, ain't no way this data is leaving our prem. Those inhibitions eroded fairly quickly.
For sure.
Yes, there are the small subset of customers that are tied to extreme privacy of data, whether it's PII and regulated type info, or it's very, very it gives us an intellectual edge over our competitors. There will always be that community that needs their own private infrastructure to do this. The vast majority can actually outsource it. And I think the way that cloud has softened the ground on those privacy concerns is going to make it that much easier for the adoption of putting AI workloads, smaller model training, and so forth in cloud and neo cloud providers. That's my prediction, October 2025. So
I don't think you're wrong. I interviewed some people for Zayo. Zayo put on a webinar series, and I got to interview some real AI experts as a part of that series. And that was one of the themes that cropped up across those three discussions.
Yeah.
Everyone's going to be using neoclouds. Almost no enterprises are going to be building their own infrastructure.
Yeah.
They're going to be looking to someone who spent all the money, built that out, and did it themselves. So even if you could get all the GPUs you needed, do you really want to power? Do you really want to maintain that infrastructure? Do you have the expertise in house, because AI compute workloads and the network demands that as a specialized task with specialized knowledge? Whether you go, in InfiniBand or Ethernet, either way, you're getting into rarefied air, finding experts that actually know how to make all of that go. Okay, so with all that in mind, let's move off the power discussion. I want to talk about some more things we ran across in New York City, Scott, that come up in my mind as enablers, for this technology that is using some kind of a language model and natural language processing, natural language interface to talk to our network. One of those was agentic AI, and then you can't say agentic AI without saying model context protocol. And of course, John Capobianco, who lives in his own very rarefied air of experimenting with things on YouTube and stuff. If you guys listening don't know John, go look up John Capobianco and see some of the crazy AI stuff he's doing with networking. Agentic AI, that is agents that are set up to do some kind of specific task on your network and have specialized knowledge, it seems to be the next wave of AI and how AI is going to be deployed. We've been hearing about this from, again, Juniper. Drew, you and I have talked to Cisco as well, that have talked about our agentic AI future that's come up. And then model context protocol is one of the enablers for this. And I heard the best description of model context protocol from John, actually, Scott, in one of his presentations. John, I think he was just focusing his session on MCP. He's like, all model context protocol is providing context to a model via a protocol. And it's like, that's so obvious. And yet now that you put it that way, it's like,
Right.
oh, that's what it is. So the key here for network engineering, I think, is to understand that a model that is provided more context around data can now present that data to you in an informed and intelligent way. This goes back also to what Selector had been talking about earlier in the day around why they have a bunch of different models and why preparing your data for ingestion into the model is such a big deal, and the fact that you need to apply metadata to that data that you're bringing into the model, because that's how all the models work together and all the pieces get put together. MCP gives us a way that, Scott, Drew, correct me if I'm wrong here, but that gives the agents a way, an interface that they can get other context around data that they're querying about, and then give you an answer that makes sense in the big picture of your network, if you've got tools out there that can do those things.
As a networker, I love this paradigm, because this just completely models client-server computing. Your agents are clients in a sense, and they're talking to MCP servers. And, if I really oversimplify this, if I have a web server that has all sorts of stuff that can be, gotten via the web server, it's just that I'm always talking to the server on a well-known port, right? There is an analogy to agents as clients asking an MCP server for different pieces of information and different tools. And this is like one of the things in the development of AI for network engineers that, like, okay, I can hang my hat on this. I can hang my favorite total network operations hat on this, by the way. I know we're audio only and you can't see my very cool hat, but so I really like this as a way to understand it and relate to it. I think you can talk about agents outside of the context of model context protocol.
Yes.
Agents have agency. Agents can do things, right? And they can be very simple. Agents could just provide a feature. I could have an agent that whenever I press the button for that agent, it goes and gets me the show BGP neighbor status for a certain BGP relationship. We're totally overrating on BGP, over-rotating on BGP stuff this episode. Sorry. But I could have an agent that collects it for everything in a particular region of the network, or I could go do very, very complex workflows, right? They've really hit the world of software development, the plugins for Cursor and VS Code, and to be able to use Claude Sonnet, to be able to use, Gemini and OpenAI models. Like, we're really seeing an impact on the software development world for agents to help build code today. So that's real. I'll stop the ramble there.
I think the question is, and it is a great context, I think the client server model, because that's how they built out the protocol. They actually call it an MCP server.
That's right.
That is, yep. Yeah. But also a network engineer listening to that example is like, okay, where's my access control? Where's my authorization? Where's my logging? So I understand who's doing what, when, and why, and am I okay with that? And the last time I looked at model context protocol, it seemed pretty lacking in those areas. I don't know if it's started to touch on that anymore.
That's come on in a hurry as they've bolted OAuth security onto MCP now. I don't know that it's full RBAC exactly, but OAuth, if you've ever had to write code that uses OAuth, it's annoying, it's painful, but you can scope what people can and can't do with that, grant permissions and so on for various behaviors using OAuth as the model. So I'm gonna make a bunch of assumptions, having not dug into it deeply myself, and go, it's not insecure. It's come a long way. It's leveraging OAuth now, and it's everybody can relax. I think we can stand down a little bit.
I think the thing to think about, though, is that we're not talking about allowing people to do things. We're talking about allowing hunks of code to do things. And that can be a much trickier problem because we don't necessarily have, an Active Directory set up for all of these agents running around. So it's like, okay, I'm starting at 0 here.
Well,
And
you just
then
said
you
a
get into
mouthful.
shadow IT. And so, yeah.
You just shadow agents. All of a sudden, we're in a Tom Clancy novel.
Good evening, Mr. Anderson. That's right.
So this was another thing that came up, Scott, in the New York City talks. Humans in the loop. That is, we're not ready to just let the agents go off and do things. We're ready for the agents to do some things carefully paid attention to and monitored, on our behalf, carefully scoped and limited with guardrails in place while we figure out what all they are going to do or not going to do, if there's any unexpected behaviors and so on. We are not talking about crank up the agents, throw them in a workflow so that they've got autonomy to accomplish the thing. We want to get there, but as of today here, and we're recording this in October 2025, we're not there. That is not where we're at with agents. And the emphasis on a human in the loop, someone reviewing the output of what the agents are doing, someone making sure that we're getting the results that we expect when the agents are tasked with a certain task, came up repeatedly.
Yes. I'm going to invoke a TNOPS, Total Network Operations Principle, on you right here. Always be evaluating, right? Totally ripped off from Glengarry Glen Ross. You see this watch? Always be closing. No. NetOps mantra needs to be always be evaluating. And like we talk about this range of, John Capobianco doing crazy stuff, right? I wouldn't call it crazy. I would say, he's the one hacking the way through the dense jungle, trying things and unafraid to fail publicly. And I mean that as a complete compliment to show what's possible, all art of the possible, right? Most of what you would see from a John Capobianco video, which are great, and you will always learn something, doesn't get plugged into your production enterprise network tomorrow. Right? There's lots of gap and testing and evaluation between, hey, I just learned how to build an MCP server, to now I know how to plug OAuth into it, to, I'm going to integrate with my Active Directory to make sure entities with identity only get the privileges they're supposed to have, right? So there's miles to go before we sleep. It's incredible. I can't believe it's 11 months. We've had MCP for 11 months, and there's already some decent security integration into it. But, this is where people need to go through, an enterprise needs to go through a POC and have a checklist. Okay, when I did this, did it properly query LDAP, or did it probably use OAuth, to make sure they really are production hardened for my environment. And that goes to having, humans in the loop too. We need humans to be paying attention today to see what's actually happening. And that's part of the evaluation process.
What's interesting, Drew, is I'm thinking back of the various change control boards that I've been a part of over the decades. And it's humans in the loop for the humans. That is, right. There'd be a proposed change that someone who was a network operations engineer tasked with accomplishing X, bring up a new interface, run this fiber, whatever it was. Here's how you're going to do it. And they would submit a change that literally had the exact code they were going to type into the different devices and the order of events and a backout plan and all the rest. And then those of us on the approval board would review that code and either approve it because, it's going to do, everything's going to be okay. Or we'd kick it back and go, hey, you forgot about spanning tree on switch 4. You've got to address it in this way and then resubmit your change. We've always had humans in the loop. And I guess with the automation of an agent, the workflow is going to be somewhat different. I think it might feel different, but I feel like we know how to do this as networkers. And in my hope in the short term with that would be that agents make us more efficient at it, and it's a little less error prone than the over caffeinated and underslept, overtired engineer who's writing a change control out by default. Or just go ahead.
Yeah, I guess this gets to the question though, that if I have to run everything through a change control board, that this quote unquote autonomous system I've bought is supposed to do for me, what was the point of buying an autonomous system?
I don't think we're buying autonomous systems yet. Right now, we're buying systems that can absorb a huge amount of information and uncover facts about our network that we did not see before. We are doing things that allow us to find signal in the noise because we got so much noise. We are enabling applications that are very specific and very guarded to accomplish things, perhaps like that Lumen example where they needed to rebalance traffic across a complex BGP network. And they built effectively a software algorithm using AI as part of the components to accomplish that very specific goal, and went through a lot of iterations and a lot of testing before it became something autonomous that they trusted. It was a major building block. When you're not, anyone that's selling you AI today, if they say they're selling you the magic bullet that is going to be like, you got autonomous network now. You just, tell it in English, hey, make sure the network doesn't suck today. It's going to figure that out. And, what for some definition of suck. No,
Right.
we're not there. Nobody's there, and no one's pretending we're there. Honestly, it's more
Well,
like
some are pretending we're there,
Some are,
but
yeah.
yeah, and we just need to filter out that hype. Sorry to interrupt you.
the adults in the room aren't pretending that. They're sure, okay, there may be some vendor hype and some marketing folks that are like, it's going to solve everything. But everyone that's actually worked with the tech understands we're in this middle state right now. We're in this transitional state where
Probably at the very beginning.
is it
of the transitional
viable?
state.
Can we do it? And that's driving this conversation apart, the viability of it. Can we actually do this? Is the result going to be, is the juice going to be worth the squeeze? We're going to spend all this money on GPUs and infrastructure and nuclear power and whatever else for our network operations use case. What's the value going to be? And it's going to be that, to me, I'd be curious to hear if you came away with the same impression, Scott, from Thursday or from New York City, whatever day it was. Thursday? I don't think so.
Tuesday last week.
Yeah. It was augmentation. It was not replacement of a network engineer. It was not autonomous operations for the network. It was figure out insights and things that we never would have seen otherwise from the network, that AI can pick that signal out and make it easier for us to uncover that information and make it actionable. Whether the AI is doing the action or not is a question we're going to keep kicking down the road a bit. I think we get there. Another example was using an MCP server to call into Itential, which had a complex workflow pre-built to pull some information out of the network and feed it back to the agent that could then move ahead. Things like that just give efficiencies to the network across huge swaths of information.
So what I'm hearing you say, Ethan, is that in my head, and this is probably my fault, when I hear AI, I'm also hearing automation. And in some ways, maybe those two things shouldn't be blended together. What I'm hearing you say is what AI is going to be really good at is using agents or models or purpose-built models or whatever to sift through lots of disparate information, summarize it, and then send that to an LLM to me to help me, the human, make a decision faster or more informed than I could in the past, as opposed to doing it for me.
Yeah, I think that's about where we are today. What the future looks like is an open question. Scott?
Yeah, no, I think that end state goes well beyond what you stated, Drew. I'm sorry, that potential end state, right?
Potential, yes.
And let me use an oversimplified example, right? The history of routing protocols, right? We started with static routes, and we hated it when an interface went down. So we created floating static routes, right? When one interface goes down, I can go over to the other static route. I decided RIP was a huge improvement over lots of static route definitions, right? But I could I could lose next hop information for 90 seconds or more, depending on the size of the network. IGRP and EIGRP came along and made that a lot faster. And then link state protocols came along to do, insert availability information and interface state information into a network much more quickly. So we effectively build all sorts of automated autonomous processes into routing protocols, because that's not stuff that humans can do fast enough, and nor would we want to, right? I could go through the same thing with TDP, LDP, and MPLS. I won't bore you with that. Why would I want to nail up static LSPs across, a 37 router hop LSP path, right? I created signaling mechanisms, RSVP and others, right, to do that for me. We're in a phase now where we're identifying these use cases that have promise for autonomous behavior. But I'll take you back to the selector example that I took from one of their leaders a few weeks ago. They're not trying to do it all at once. They're trying to take a use case at a time and make sure what they're doing works. And they're not forcing you to accept autonomous behavior. The hooks are in there for the human to still click OK before proceeding. And I think that's absolutely necessary if you ever want to hope to build trust in actually using it for autonomous operation in the future for a given set of use cases.
For sure.
Yeah, another thing in there, Scott, that we haven't actually touched on yet is that everyone's set of models are going to be different depending on what their tech stack is, what their use cases are, their goals. That is, it's going to be hard to buy an off-the-shelf thing, send telemetry to it, and magic comes out the other end. It's not going to go like that. Selector they made that point sharply several times. Like, guys, this is a significant engagement that's going to take a lot of time to get to a point where the model is producing results that are useful to you and you're getting wins.
And you did touch on data a little bit a while ago, and I think we should spend a little time on that before we have to call it a day here. I think in 2026, we'll be talking about making data engineering great again.
How do you mean?
So remember 5 years ago when data science was all the rage, right?
Because of like big data and data warehousing and all that.
Correct. Yep. Well, guess what the raw material is for training any model? High quality data. Well, it doesn't have to be high quality data. If you don't care about the outputs you get, you don't care about the garbage you put into it, right? So, my horrible example is that Word document that has been done a save as 17 different times with minor edits on each version of that document. That's sitting in your SharePoint. And if you want to say, I want to build an enterprise model that includes these 17 versions of a document that might conflict, might really contradict each other, I need real cleanup on that data and those inputs if I ever want to have good results from the models that will result from it. I think as more enterprises get into this, they're going to find, metadata definition, model definition, data tagging, data cleanup. And data engineers will do the work, not data scientists. The data scientists will be like the architects who figure out the overall architecture. There'll be 10x more jobs for people doing data engineering. I see that coming, as early as rising into 26.
All right, I want to end on one provocative question here, which considering, let's say that we haven't come to any firm conclusions, right? But let's say that we agree NLI, a natural language interface, is going to replace our CLI, that's coming someday. It's on the time horizon. If that's true, should network engineers keep investing in learning tools such as Ansible and Python? That is tooling, code, libraries that can help with network automation? Or is it just pointless because at some point I'm just going to be able to ask an NLI a plain English question and get an answer back?
It's too early to discard traditional techniques that work. Don't stop investing in Python and Ansible or Go if that's what you want to use for network automation. We're too early in the process to say this is definitely how everything is going to be done a year from now. And even if we make that decision a year from now, it's going to take another 2 or 3 years to actually implement. So that subject matter expertise in scripting languages, in other technical domains, how will you know if a model's wrong if you don't have the expertise to judge that? Do not defund your Kirk Byers Python for networking courses. Sorry, Kirk. And many other good courses out there available. It's just not time yet. Always be evaluating.
Yeah, and let's not forget we are in an AI bubble. I don't know what the fallout is going to be when AI build outs and spends normalize. What's left? There are going to be some losers, there's going to be some data centers that go on fire sale or some such. I don't know what all of it's going to be. The technology is not going away just because the bubble's bursting eventually. It will burst. We just don't know when or what that looks like. But I believe the value that we're beginning to see from AI applied in the various ways it's being applied to a lot of IT disciplines, including network operations, means no, guys, this is real. This isn't going away. There's something here. And so if you're of the mindset of, screw it, I never had to learn IPv6 after all these years, I'm not getting into this AI thing. There's something here. There is definitely some value here. And I'll throw another question out at you if you're still listening at this point and haven't gotten so irritated you clicked away. Has the value of a network engineer ever really been in your ability to configure a device? And if you're like, well, yeah, I know how to type the commands to make the blinky thing blink. You do, but anybody can look up that information. I argue that your value as an engineer is in understanding the system as a whole and how to put it together so that you're delivering performance and business resilience, and these kind of things that the business cares about. The configuration element, while super technical and nerdy and interesting and all the rest, that's not the valuable part. From a certain point of view, that's not the valuable part. And so if a natural language interface were to come away and make your knowledge of a specific command line architecture irrelevant or an interesting bit of past history, your value doesn't go away. Your value doesn't change as an engineer, in my opinion. I don't know if am I wrong, Scott?
I will push back in the following way. Beware of false mutual exclusions. Is your value only in A, understanding how it all works together, or only in B, knowing how to actually type the commands? And I would point to any network equipment certification program that has tiers, right? Of course, you start out with minimal skills and you build, but you bring additional value if you really do understand how it all comes together. I'm not going to say it's all in one bucket or the other. I will say the more we're able to automate this, the less dependence we will have on humans needing to execute CLI commands. Not going to say it'll go to zero ever, but we're going to become less dependent on that for sure.
You were talking about certifications with tears, and immediately I thought of crying, and then quickly realized you were talking about the other kind of tears.
That is fair. I understand the reaction. Yeah. Yes.
Okay, guys, great conversation that I hope as you're out there listening, we didn't just hit this up for the sensational aspect of AI. Let's talk about AI some more, but more, Scott and I sat in a room for a day where people were talking about practical applications they were coming to with using artificial intelligence and how they were doing it. That is, it was the hands-on practitioner approach primarily that was being discussed. And so the real stuff was happening in that room, people talking about it. So it felt useful to have a follow-up discussion about that. Hey, Scott, people can follow you because you are very active on the internet, sir. So let them know how to find you.
LinkedIn is the best place. I really have centered on that for anything I'm writing, anything I'm thinking about. My DMs are open. Feel free to reach out. Be happy to connect with you.
That's Scott Robohn, Robohn. Scott Robohn. You can
Nicely
find him,
done.
as he said, on
Thank you.
LinkedIn. Well, it's right in front of me in your Zoom square. All I had to do was read it. So but thank you.
We might automate that someday. Yeah.
And you can find me, Ethan Banks, and Drew Conry Murray. We are also on LinkedIn. And Drew, you still active on Blue Sky? Still doing the Blue Sky thing?
Still doing the Blue Sky thing. Drew CM at Blue Sky. Yep.
And I still have my Blue Sky account and haven't logged in months now. So I'm not proud of that, but it is what it is. Okay. Thanks to you out there listening. Thank you for listening to Heavy Networking. We do appreciate it. And appreciate you allowing us to consider the possibility that AI in some form or other might abstract away network operating system syntax, maybe even in the near future. And if you agree, disagree, have other input, maybe you yourself are a hallucinating LLM, or you're just shaking your fist at clouds, you can let us know all your feelings via packetpushers.net/follow-up. Like, subscribe, and leave a comment on whatever platform you use to listen to us. Like a mutating virus, we are everywhere, including YouTube. Hey, all the shows on the Packet Pushers Podcast Network will be consumable as video eventually. It takes time, guys. For those of you that care about this, it does take time to move our production workflow from audio to video, but we are getting there one show at a time. We have even hired someone. We got a new full-time team member to help us make that jump. So if you're paying attention to our YouTube channel, you're going to see more and more of our shows upgrading from the audiogram that you see today to the talking heads format, and maybe even some diagrams now and again. We'll see. And those shows are going to be joining the shows we've already converted to full-time video. That is N is for Networking, Life and Uptime, and the Cloud Gambit. Those shows are all video where you can see all of our lovely faces as we make our moist mouth noises. Meow, meow, meow. Okay. Hey, you're a pretty awesome person, and we all care about you here. We really do. And so reach out if you need anything, even if it's just to talk. We'll happy to grab some time with you and just discuss what you're dealing with. We know things are tough out there for a lot of you, and we're paying attention. You're seeing. Until next time, just remember, too much networking would never be enough.